Hey everyone, and welcome right back to the Explainer. Today we are diving into elegance and readability in Haskell, and specifically we're making the case for a little function called maybeToList. Look, we are exploring a battle literally every developer faces, whether you're just starting out or you're a seasoned veteran. We're talking about that eternal everyday struggle between writing clever code and writing readable code. We'll be drawing from some really fantastic recent notes by a developer named Ang, who documented this deep dive into Haskell programming. If you've ever stared at a line of code and felt like you were trying to decipher some ancient cryptic riddle, trust me, this explainer is going to be incredibly validating for you.
Okay, let's dive into this, because this is exactly where the high stakes of maintaining a clean codebase really start to show themselves. So Ang was dealing with the pretty standard task of parsing metadata, and a big question popped up. Aren't there better ways to improve the readability of this process? Because when we're actually building software out in the real world, readability isn't just some nice-to-have bonus. It's the absolute foundation of maintainability. If the next person looking at the code base, and hey, let's be real, that person might actually be you in 6 months, if they can't understand it at a quick glance, you've got a serious problem.
To show you exactly what we mean, here is the initial code snippet Ang was wrestling with. Return, $maybeID, the cons operator, maybeMeta, body. Now, if you look at that and immediately feel a slight headache coming on, you are definitely not alone. This is exactly what Ang calls out as code that forces us to mentally decipher the logic. It's just incredibly dense. I mean, it does the job, sure, but it places a massive cognitive burden on whoever has to read it next.
So what's really going on in that snippet? Well, it's a heavy reliance on what's called point-free style. As we know, this functional paradigm intentionally omits explicit arguments, usually for the sake of mathematical elegance. And while this style is absolutely a staple of Haskell, these clever functional tricks can seriously harm readability. That's especially true for newer team members, or really anyone just trying to quickly scan through a file. It's an approach that entirely prioritizes brevity over absolute clarity. So how do we actually fix a headache like that? Well, Ang's first attempt was to just write a custom helper function to make the logic completely explicit. Step 1. Create a prepend maybe function. Step 2. Handle the nothing case, where you just return the body. And Step 3. Handle the just case, where you actually prepend the metadata to the body. Now this absolutely works, and it completely strips away that confusing point-free syntax. But, unfortunately, it adds a bunch of extra boilerplate to the project. You're suddenly writing and maintaining custom logic for what's actually a relatively simple operation.
And this brilliantly illustrates Ang's ultimate breakthrough. Contrast the mentally taxing point-free code on the left with the new solution on the right. Return, $maybeToList, maybeMeta, concatenated with the body. Just look at how much easier that right side is to read. It's practically plain English. You are taking a maybe value, turning it into a list, and simply appending it right to the body.
Why exactly does this alternative win out so decisively? The source breaks it down perfectly for us. First off, it reuses the existing standard library by just importing maybeToList. You aren't constantly reinventing the wheel with a custom helper function every time. Second, it keeps the code incredibly clean. Third, it provides a significantly better data flow. And finally, because of that straightforward data flow, it is far easier to scan and verify. It basically replaces what Ang calls primitive obsession with a standard, highly readable library function.
Now, what's really fascinating here is how Ang actually stumbled upon this elegant solution. It wasn't by digging through hundreds of pages of documentation or searching forums. It was actually by using a more advanced AI model. Ang notes that this particular model is currently free to use, though it likely won't stay that way forever, and it vastly outperformed the basic AI models they usually rely on for daily routine coding tasks.
This exact discovery led Ang to a really fascinating crossroad, posing this exact question: should I subscribe to the current cutting-edge models? It's a question basically every single developer is wrestling with right now. Now, Ang's conclusion was to actually hold off for now, mainly to maintain a steady coding pace for study purposes. But it sparked a secondary, perhaps way more profound realization. Maybe the secret isn't paying for the most expensive AI out there. Maybe it's just learning how to prompt the AI more effectively to get these standard library solutions in the first place. Prompts for better code, engineering AI for readability. Let's move on and see how this builds into practical, usable strategies for all of us. Based on this entire experience, Ang engineered 2 highly specific prompt templates designed to literally force any AI to generate idiomatic, readable solutions rather than overly clever code.
The first template is what Ng calls the constraint-focused prompt. The core of this prompt explicitly tells the AI to avoid clever, functional tricks, point-free style, or complex partial applications. It flat-out demands that the AI prioritize explicit logic and standard library functions that are easy to scan. By explicitly laying out these constraints up front, you are actively preventing the AI from showing off its ability to write obfuscated, mathematically dense code, and you're forcing it to write code a human can actually maintain.
Then we have the second template, which is the Ada philosophy prompt. This one is absolutely brilliant for long-term project goals. It frames the request around prioritizing readability, maintainability, and safety over syntactic brevity. And I love this specific inclusion right here. You explicitly ask the AI to suggest a way that is idiomatic but remains easy for a junior developer to understand while avoiding unnecessary abstraction. You're essentially giving the AI a very specific persona to embody, that of a senior mentor who cares deeply about the long-term health of the team and the entire codebase.
So the crucial point is that both of these prompts actively enforce a core set of foundational rules for good code. Avoid clever tricks, prioritize explicit logic, rely heavily on standard libraries rather than your own custom boilerplates, ensure readability for junior developers, and avoid unnecessary abstraction. When you engineer your prompts around these specific pillars, you completely bypass the AI's tendency to write that dense code, and you arrive at elegant, simple solutions like maybeToList so much faster.
To give you a quick cheat sheet, here is how you might choose between the two. Use the constraint-focused strategy when your primary goal is preventing obfuscation and complex partial applications. Basically, use this when you have a piece of code that looks like alphabet soup and you just need to untangle it. Use the Ada philosophy strategy when you are focused on long-term project goals and you want to guarantee that your entire team, regardless of their experience level, can easily read and contribute to the code.
As we wrap up this explainer, we really want to leave you with the exact question that Ng's insightful discovery brought to light. As software development continues to rapidly evolve, will you rely entirely on paying for the most cutting-edge AI to write your code for you? Or will you master the art of the prompt, shaping the tools you already have to prioritize readability, simplicity, and true elegance? Thanks so much for joining us on The Explainer, and happy coding!